Dear students, in this session we are going to see about CSMA, Carrier Sense Multiple Access. The main objective of CSMA protocol is to minimize the chance of collision, thereby increasing the network performance. It is based on the principle sense before transmit. When a station is ready with the data, it is sensing the channel first. When the channel is identified to be free or idle, then only the data is being transmitted in the medium. So this is a basic principle behind CSMA protocol. Though CSMA is trying to reduce the number of collision, it can't completely eliminate it because of propagation delay. So the vulnerable time in CSMA is the propagation time itself. When a station sends a frame and at the same time if another station is sending a frame, definitely it will result in collision. But how it is happening in CSMA? Let us see. When a particular station is sending the data, the first bit of the frame will be taking some time to reach the other end of the medium. Within this time, if any other station is sensing the channel to be free and start its transmission, the result will be collision. Let's see in this diagram. So let us see, these are the stations A, B, C, D. At time T1, A is transmitting a frame. So it will take some amount of time. It is taking amount of time. The first bit of this frame is reaching the B's point. So within this T time, if B is sensing the channel and if it finds the channel to be free, B will start its transmission. Because before the time T, B doesn't know that A is transmitting its frame. Here collision will occur. Collision will occur between A's frame and B's frame. Okay. Not necessary to be here. After some distance, the channel, the collision may occur. So till the first bit of the frame A reaches the end of the channel, end of this medium, it is vulnerable. It is vulnerable to collision. So we are taking this entire duration of time as vulnerable time. There are three methods of CSMA: one persistent CSMA, non-persistent CSMA, and P-persistent CSMA method. Let's see one by one. First, let us look at one persistent CSMA protocol. This is very simple and straightforward mechanism. When a station is having the data, the station is ready for transmission, it start sensing the medium. And if the medium is found to be ideal, it sends its frame immediately with the probability of 1. That means without waiting for anything, it start transmitting its data. I can see it here. At this point, a particular station is sensing the medium. So here the medium is busy. It is carrying some other signal. But persistently, look at the word persistently, the particular station is sensing the medium continuously. After some time, when the channel becomes free, it transmits its own data. So here, I think you may get the answer why we are calling it as persistent, because it is continuously, persistently listening the channel till the channel becomes free. Once the channel becomes free, it starts its transmission. So what is the advantage in this method? Means it is very simple to implement, and the particular station is persistently listening the channel. It does not waste any time. Once the channel becomes free, it can start its transmission immediately. But what is the drawback here you are having is, when two stations at the same time, if they are sensing the channel to be ideal, to be free, both will start transmission. If both are transmitting its frame at the same time, the result will be collision. So still the chance of collision is higher in one persistent CSMA protocol. The next type is non-persistent CSMA protocol. In non-persistent CSMA protocol, when a station is having the data for transmission, it senses the medium. If the medium is idle, or if the medium is free, immediately the data will be transmitted. Otherwise, if the station finds the medium to be busy, it waits for random amount of time. Here in diagram you can see the difference. So here continuously the station is monitoring the medium, sensing the medium. But look at here, when a particular station is sensing the medium to be busy, it waits for random amount of time. It does not persistently continuously sensing the medium. It waits for random amount of time, again sensing the medium. Again, if it is busy, it increases the waiting time. Obviously it have to increase the waiting time, and after sometimes it finds the medium to be free, then start its transmission. So advantage of this non-persistent method is, when the station is identifying a channel to be busy, both the station will be having the different wait period, because this is a random number. One will be waiting for 10 milliseconds, another station will be waiting for 20 milliseconds. So again, when they are sensing the channel, the chance of collision will be very less. But what is the drawback in this method is, at this time, if you're looking at the diagram, at this time the channel is free from the transmission. But unnecessarily this much amount of time a particular station waited, though the medium is free, because of its random choosing of number, it is waiting for more time, then only it is sending the data. So unnecessarily the channel resource is going waste in the non-persistent CSMA protocol. Now I think we'll be getting the meaning of non-persistent CSMA protocol. Here persistently, after fixed amount of time, the station is sensing the channel. But here it is not persistently sensing the channel, it is waiting for random amount of time, then only it is sensing the medium again. So it is called as a non-persistent CSMA protocol. Next comes P persistent CSMA protocol. So the best strategies we followed in one persistent and non-persistent, we built it as P persistent CSMA protocol. And this protocol is particularly used for uh, the channel sensing which has time slots. That means, so let me take this as a medium. At this point, a particular station A is sensing the medium. Since it has to transmit its data, then one persistent continuously it will be sensing. But in a time slot, if it is listening the channel in the particular time slot, some predetermined slot period it have to wait. Okay, after some time only, here only it should start sending. Again it have to wait for this time slot, then the next sensing time should be the next time slot. So likewise we are dividing the times into slots. Only at the starting of the next time slot the next sensing should happen. So let us take an example. A station is listening the medium. When it is listening the medium found to be idle. The channel is free, but immediately the station won't transmit its data. It will be choosing a random value P. So based on this value P, it will decide it will be sending its data or not. This P will be compared with a threshold value. Then if the P is lesser than the threshold value, data will be transmitted. If P is greater than the threshold value, the data won't be transmitted, or vice versa, can be anything. So with the probability Q equal to 1 minus P, the station will be waiting for the next time slot, then again checks the line, again the cycle repeats. So whenever it is sensing the channel, it will be sensing the channel is free or busy. Even though if it is free, it will be sending the data based on the probability value. So these are the small base mechanism we try to reduce the number of collisions. Okay. Let's see the flow diagram. So one persistent, when the station is listening the channel and the channel is busy, Continuously we are sensing the channel. If the channel found to be idle, station can transmit. One persistent, very simple. In non-persistent, the station is looking at the channel is busy, it waits for random amount of time. But here in one persistent, continuous sensing, continuous listening is there. Here it is waiting. That means the station can go to sleep. After some time, after waking up, again it can look at the channel. Then if the channel is free, it can send the data again. Otherwise, it can go for another waiting period. Then it can again sense the channel. So this is a non-persistent. In P persistent, the station is sensing the channel. The channel is busy. Again, it follows the one persistent mechanism, continuously sensing the channel. The other case, when the channel is idle, it is choosing a random probability value P. Then based on the value of P, it is taking the decision. The data can be transmitted, or again it have to wait for another slot. Is there any logic behind, even though the channel is free, why it is waiting? Yes, the answer is, the problem we are having in one persistent is when two stations are identifying the channel to be free, channel to be idle, both will start the transmission. But in P persistent, we are avoiding that. Even though two stations are finding the channel to be free, their probability value will be differing. One will be choosing the P value 0.2. Another station will be choosing the P value 0.4. So based on this P value, it will take the decision whether it can utilize this time slot or it will be utilizing the next time slot. So that we are again adding one more factor, one more point to reduce the chance of collision. Okay. Thank you.